So this video is about reduction of alkynes. So we're going to take a triple bond and add hydrogen to it to turn it into a double bond or a single bond. And there's a bunch of different ways to do that, and they're really useful for synthesis. So catalytic hydrogenation, which we talked about when we did double bonds, is the most common way to reduce a pi bond. And just to recap, we saw this in alkenes. So if you have a double bond and you add hydrogen with a catalyst, it's typically platinum or palladium or nickel, and I pretty much always just pick platinum because it's habit, but any one of these catalysts would work here. It's going to do the reduction and add hydrogen and give you the single bond. Very similarly to that, if you have a triple bond and you add hydrogen with a catalytic hydrogenation catalyst, and it will also do the reduction and it will reduce it to the single bond, to the sigma bond. Is it possible to stop at the addition of just one equivalent? You're probably wondering that, and I'm glad you asked. What would this look like? It turns out it is not possible with the typical catalysts that we always use. And the reason why it's not is that it would do the first reduction here. You take the triple bond, it would reduce it to the double bond, but it turns out that we cannot stop here because the alkene, the double bond, is more reactive than the starting material. So this would go slower, and then the second step would be faster, so we would not be able to stop it from adding. If you tried to be really careful and just add one equivalent, you'd get a big hot mess. You'd have a few things that were reduced twice and some that weren't reduced at all. It would not work. So what if you really, really want to stop at the double bond, though? It turns out that there is a way to do it. And that is to use what's called, it's a partially deactivated catalyst. So the catalyst has something in it that helps it not work very well. It's called a poison catalyst. And there's a few different ones. The most common one is called Lindlar's catalyst. They throw in, I think it has quinine added. It's pretty complicated actually, so I'm not gonna draw the structure. If it says Lindlar or Lindlar's catalyst, it means that it's a poison catalyst and it will stop at the double bond. There's a couple other ones. I think they show up later in the notes, so just keep an eye out for those. But Lindlar's catalyst is definitely the most common. And what it does is this. It does the reduction and it stops at the double bond because of the poison, and it always gives cis. For the same reason that catalytic hydrogenation always adds the two hydrogens to the same side, that still happens. We always get the cis double bond, always. If you want to make the trans double bond, if you want to reduce it to a double bond but you want it to be trans, there is a way to do that. And this is called, it's called a dissolving metal reduction. And what happens here, it's actually, the mechanism is really complicated. It's given in a different chapter in Klein. It's a radical mechanism, and it's given in the radical chapter. So I'm not going to talk about it. But what it is sodium, which is a metal, is put into liquid ammonia. So ammonia is a gas. It's liquefied at really low temperatures, and sodium is added, and it dissolves. It's really actually a really strange, kind of cool reaction. And what it does is it adds hydrogen to things, and that's the only thing that we need to know for this. Because of the mechanism, when it makes the double bond, it always gives you trans, which is really useful when you want to make that, so it's a really handy reaction. This is also called a Birch reduction, but that's something that that word shows up later on in the book. So just to summarize these reactions, it's kind of nice to keep everything straight. We've now know a whole bunch of different ways to reduce things: triple bonds to double bonds to single bonds, and triple bonds to single bonds. And how can we do that? And this is just a summary. So if we start out with a triple bond, this is 2-butyne, and we want to reduce it all the way to the single bond, we can do that using catalytic hydrogenation, hydrogen with platinum or palladium or nickel. If we want to go halfway and go to the cis double bond, we can do that by doing the hydrogenation but using a poison catalyst, such as Lindlar's catalyst. Then we can take that double bond, if we wanted to reduce it the rest of the way, we would add a normal hydrogenation catalyst, and we could do that. If we wanted to make the double bond, we would use the dissolving metal reduction, which is sodium and liquid ammonia, and that would give the trans. That trans double bond could then be reduced all the way, if we wanted to, with a typical catalyst, hydrogenation, hydrogen and platinum. Just because it's not in the notes earlier, if you could add this nickel boron compound is another poison that can be added. So you can use either Lindlar's catalyst or add, I don't know what this is called, but nickel bromide is another possible way, and it will do the same thing that Lindlar's catalyst does, just so that you have that, because it shows up later in a problem. Okay, so that's just the summary, and so using that, just a little bit of practice. So here are some alkynes, and draw the product that you would get for these reactions. So the poison here, hydrogenation with a poison catalyst, is going to give the cis double bond. Hydrogenation with a normal catalyst is going to go all the way to the single bond. And if we have a triple bond and we add sodium and liquid ammonia, then it's going to give the double bond, but it's going to be trans. And then again, just to practice, try to do this without looking at your notes to start to try to remember these. If we have a reactant and you're given a product, how will you get there? It's just a different way to look at the same problems. Go through and fill these in, stop the video, and then turn it back on to check your work. Okay, so again, sodium and liquid ammonia will give the trans double bond. Hydrogenation will give a single bond. A poison catalyst will give the cis double bond. And the dissolving metal will give the trans double bond.